So, the first question is from GATE 2013. I'll read the question. The relativistic form of Newton's second law of motion is. That means, in this question, you have to find out the relativistic form of Newton's second law. So, you know that Newton's second law, force is equals to rate of a change of momentum, right? This is Newton's second law. And momentum is equal to m into v, mass into velocity. Mass of an object and the velocity with which an object is moving, both of them multiplied to give momentum. So this is the non-relativistic case. Case meaning when particle is traveling with the speed very smaller than the velocity of light. Suppose there is some particle, when it is traveling with the speed comparable to the speed of light, then we apply relativistic mechanics. Okay. So here you can see that now how to solve this, now how to find out force in relativistic form. So to find out force, first what you will do, you will see momentum. Momentum is equals to m, sorry, rest mass into v. This is the classical case. But in relativistic case, you know that you will replace mass with m is equals to m naught upon under root 1 minus v square by c square, right? Right. So here I'm denoting rest mass with m. Okay. Don't confuse. Don't get confused. Okay. So here, wait. Let me change it. M is equals to mr is equals to m upon 1 minus v square by c square. So this mr is relativistic mass and this m is rest mass. Okay, so that there won't be any confusion. Yes. So it started from 7 o'clock because last week I took 2 hours class because I didn't take one. I didn't take before that one class, so I have to compensate for it. So that is why I took 2 hours class last week. Yes, 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 as usual time, huh? Oh, okay, so okay, okay. Sorry, sorry, my bad. I'll inform you beforehand. Before, okay. Sure, sure, sure. Okay. So in this question, if you see, we are asked to find out the relativistic form of Newton's second law of motion. So you know Newton's second law of motion is force is equals to rate of change of momentum, right? And momentum is equals to m into v. This is the classical case when there is an object of heavy mass moving with the velocity v, so you are finding the momentum of that particle. But now consider a case where the particles are actually moving with the speed comparable to the speed of lights. So in that case you have to shift from classical to relativistic form, right? So all the formulas that you have in your classical mechanics, from momentum, from force, they need a slight modification. So we are doing that modification and finding out the formula for force, Newton's second law of motion. So we can see here that generally we write momentum is equals to p is equals to mv. But now here m should be replaced by, in relativistic case, m is replaced by, suppose this is relativistic mass. So this is equals to m upon 1 minus v square by c square. You know this formula. And this m is rest mass, right? Now if you apply here m upon under root, sorry, 1 minus v square by c square v. Okay, but force is dp by dt. So we will differentiate it. Now we will see here. Uh, what was momentum? mv under root 1 minus v square by c square. So dp by dt is equals to differentiate it. First, we will differentiate v. So we will get dv by dt, right? And 1 upon under root 1 minus v square upon c square will remain like this. Now the next case is this 1 upon under root 1 minus v square by c square will come on the numerator, so it will have value minus 1 by 2. So minus 1 by 2, 1 minus v square by c square, minus 1 by 2, minus 1 is minus 3 by 2, and then we have minus 2v by c square, right? This is just simple differentiation. So we have terms like m dv by dt. There is one term, and the other term is we have this 2 will cancel, and this negative negative will become positive. V square by c square m 1 upon 1 minus v square by c square 3 by 2. Right? I'm taking it in the denominator. dp by dt is equals to, take things that are common, like, oh sorry, here this will also come na, dv by dt, because v, yeah, dv by dt will also come. You can also do the differentiation with me and tell me if I'm going wrong on any step. Okay, okay. 1 upon under root 1 minus v square by c square. I'm taking 1 m dv by dt into 1 upon under root 1 minus v square by c square common from both the terms. Okay, m dv by dt this. So now you can see here it will be v square by c square under root 1 minus v square by c square, because 3 by 2, if you are taking minus 1, then what you will get? 1 by 2. So I have taken 1 by 2 from this term, so I'll be left no, where, maybe I'm, oh, okay, yeah, uh, square root, no, square root, yes. dp by dt is equals to m dv by dt under root 1 minus v square by c square. Then take what denominator of this? Hmm? 1 minus v square by c square. Here you will get 1 minus v square by c square plus v square upon c square, right? So this will cancel each other. And then what we will get? M dv by dt 1 upon under root 1 minus v square by c square. From here we will get 1 c square will go there, c square minus v square, right? This will get, and then it will be m c square m, this time I got here it will be c square minus v square. This will be 1 upon under root 1 minus v square by c square dv by dt. This and what is the answer for it? M c square, m c square c minus v There is some calculation is mistake from my end. I have to look up again where I am going wrong. So this is the first term. M V under root 1 minus V square. dp by dt is m. So first term will be dv by dt under root 1 minus v square by c square will remain the same. So the second term is will be v. So this will go above, and it will be minus 1 by 2 1 minus minus 3 by 2. Then this term will be minus 2v upon c square dv by dt, right? Then here it is 1 m dv by dt under root 1 minus v square by c square plus v square upon c square, and 2 will cancel, and m is inside, m I'm taking inside, then 1 minus v square 3 by 2 dv by dt. And then I'm taking m dv by dt upon under root 1 minus v square c square common, 1 plus v square by c square upon inside bracket 1 minus v square c square. Okay, this term will become 1 minus v square by c square. This term will go here. This will cancel. M dv by dt under root 1 minus v square by c square. Okay, yeah, yeah, yeah. Yeah, correct. Because this whole term will become mass, na? This whole term, yes, correct. So this is m naught, rest mass. Okay, this is m naught, rest mass. Here also, this is m naught, rest mass. M naught. This one is correct formula. So this whole term m naught upon under root 1 minus v square by c square will become mass of the particle which is moving with the speed comparable to the speed of light, and this will become c square upon c square minus v square dv by dt. Okay, I hope this question is clear to everyone. This mass is relativistic mass, huh? This is relativistic mass, not rest mass. Okay, keep that thing in mind. Okay. So I hope the previous question is clear to everyone. Now I am moving on to the next question. So this question, I'm reading the question first. Here, the total energy of an ionic solid. Suppose you have NaCl crystal, right? This is ionic. Na is positive, Cl is negative. So the total energy of an ionic solid is given by an expression. So energy is given by this expression, where alpha is the Madelung constant. So Madelung constant is just characteristic of an crystal. Okay, it is used to find out the potential. Now R is the distance between the nearest neighbor. Suppose you have NaCl crystal like this way. Huh? So Na and Cl are placed in these lattice points, right? Okay, suppose this is Na. I'm just making a dummy sample, dummy crystal. So bear with me. So like this way, suppose Na positive are placed in all these position and Cl negative are placed like this. So there is some crystal. Okay, so R is the distance between the nearest neighbor in the crystal and B is a constant. If R naught is the equilibrium position and R is the distance between the nearest neighbor, suppose Na and Cl are nearest neighbor and the distance between these two is R, and R naught is the equilibrium position. So you know the difference between R and R naught is R naught is the position when each particle is experience a minimum force or minimum energy. You know the crystal is stable or any system is stable when it is experiencing a minimum force, or it has minimum potential energy. Like the same concept we are applying here. So this whole crystal and the ions present in this crystal will be in equilibrium position when they are experiencing the minimum force. So for that, dE by dr is equals to 0 when at equilibrium position when R is equals to R naught, because it is given in the question. So R naught is that equilibrium separation where the ions that are placed in the lattice will experience the minimum energy. So that E is given to us total energy. So dE by dr. Do with me also, huh? You, all the people who are joining, who have joined here, so start doing with this, with me, all the questions. Okay. So you will get, it will be helpful for you because it is like practice session for you, na? You are getting knowledge plus also you are doing numerical with us. So try to minimize this time of doing calculation. So dE by dr is equal to 0. Differentiate this expression. Minus alpha e square 4 pi, huh, r will go to numerator minus 1, then minus 1 upon r raised to the power 2. Okay, then here also this r will go to numerator minus 9, so 9 r, minus 9 minus 1 r raised to the power 10, and b will remain like this, is equals to 0. So I'm taking, do I have, no, I'm taking this to this side. Alpha e square upon 4 pi epsilon naught. R is equals to R naught because at equilibrium position, right? And B 9B is equals to R naught 18. Sorry, 8, 18, 10. So we have to find out B, alpha e square R naught 10 upon 36 pi epsilon naught R naught square. So this will become 8, right? So this is the answer. Alpha e square R naught 8, R naught raised to the power 8, 36 pi epsilon naught. I hope this question is also clear to everyone. Wait. Screen? So is it problem with everyone is facing the same problem? So others, okay, others can see. Okay. I, are you sure you are not able to see this screen of mine? Not able. So others are facing the same position. Sorry, same problem. Sazel, Sayantan. Are you guys, you guys can see, na? Okay. Then I think Harish, you can, you can means like rejoin this meeting so that it will be clear to you because others are not facing the same problem, na? So try to rejoin this meeting, huh? Am I audible? Okay, okay. Try to rejoin, huh? Let me go to the next question. So in this question is, consider a wave function. Consider a wave function a e raised to the power I k r naught by r. Okay, where a is the normalization constant. Now for r is equals to 2 r naught, sorry, for r is equals to 2 r naught, the magnitude of the probability current density up to 2 decimal place in the units of this, you have to find out this magnitude of current density. Are you aware of magnitude of current density? Do you know the formula for this, finding out the probability of current density? There is a direct formula for it. This is the direct formula. But I'll tell you how this formula is coming, how we are arriving at this formula. So first of all, this probability current density will tell you the rate at which the probability is varying. Suppose we have this wave function, right? Xt. Now we have a space from minus infinity to infinity. So there is one position here whose coordinate is x, suppose. So the probability of finding this particle will be like this. If I'm saying that I can find the particle at this position x, so there will be high chances that particle will be found at this position will be most. And if you are going from minus infinity to the other side, extreme side, the probability of finding that particle will go on zero, will be reduced, and at one point it will be touching zero for infinity, right? So similarly, how this probability is changing with time, that define your probability current density. So to find out this formula, so this is the straightforward formula. In fact, in examination, you don't need to do the derivation of this. You should know how this formula means. You should memorize this formula because this question will come. So you don't want to waste your time in deriving this, na? But I'll tell you how this is coming. So we have, what is the probability of finding the particle at a position x in a volume element, in a length element dx? What is the probability? Psi xt square, right? This is the probability density of finding the particle, right? And now integrate it for all the space. You will find out, you will get the probability. So this is the formula, right? This is the probability of finding the particle in space. Now if you see here, so you are asked to find out the rate of change of it. I'm taking derivative part inside, right? Now I'll solve this part. So d by dt sine square is equals to d by dt. Now I'm differentiating. Can you see my screen? Yes. O- Okay, okay, okay. Then let me again share my screen. Okay, let me again share it. Okay, I'm again sharing my screen, huh? Is it visible now to everyone? Harish, right? Is it visible now to you too? Okay. Okay, I'll forward you my this PowerPoint presentation. I will mail you. So as of now, what I'm telling, you can listen to it. I will forward you this. Okay, okay then. this question. So we were here. So now I am differentiating this part. D psi by dt plus psi d psi star dt, right? What you need to do? Write Schrodinger equation. So this derivation is not necessary, but I am doing all this derivation to know, to tell you that how this form is coming. So Schrodinger equation is minus h cross square upon 2m d2 psi by dx square plus v psi eta h cross d psi by dt. Right? Now, what you have to do? Take this eta h cross on left hand side. So you will get d psi by dt is equals to minus h cross square upon 2m eta h cross. If I'm doing anything wrong, please tell me, huh? 1 upon eta h cross v psi x. Here also x is there. D psi by dt is equals to this h cross square, and h cross will cancel. There will be one h cross. If I'm multiplying it eta numerator denominator, then this eta square minus 1. So this minus minus will cancel and we will get eta h cross upon 2m, right? D2 psi x by dx square plus, again I'm doing eta numerator denominator, eta and eta square, eta square minus 1. So eta upon h cross v psi upon h cross. Okay, right? So you got d psi by dt. So this term you got d psi by dt. Now d psi star by dt is very easy. This is the complex conjugate, na? Psi and psi star, they are complex conjugate. So what you need to do, just minus eta h cross. Eta term will take negative sign. If it is positive, it will become negative. If it is negative, it will become positive. Right? Science star. Sorry, science star. It will be science star. Huh? Now, put these values here. You know d psi by dt value. You know d psi star by dt value from Schrodinger equation. We have done this. Now put here d psi star by dt. I am putting this value here, huh? In this. See, first of all, what we did, we know the probability of finding out the particle in all space. I'm just doing differentiation of it. Huh? So I'm taking differentiation inside the integration, and from that, what I'm doing, differentiating this probability density of finding the particle. So d psi by dt is psi star psi. I can write it like this. Psi star I'm taking outside, then d psi by dt plus psi and d psi star by dt. So now I should know the value of this d psi by dt. Where is this pen? D psi by dt and d psi star by dt. So for that I went for Schrodinger equation and found out d psi by dt value and d psi star by dt value. Now I am again putting the value here. Psi star. Okay, psi star d psi by dt. This is minus, okay, mm, eta h cross minus eta h cross upon 2m minus eta h cross upon 2m psi d psi star. So d2 psi star upon dx square plus eta v psi star upon h cross. Okay, plus phi d psi star by d. Okay, have I? Okay, this will be plus and this will be minus. Sorry, I just flipped the sign. And this is minus eta h cross upon 2m d2 psi. This will be psi. Do with me, huh? This calculation. If I am doing any mistake, please inform me. Dx square plus iota h cross, sorry, iota v upon h cross sine star. So you can clearly see here that these two terms are cancelling each other. These two terms you can see here cancelling each other, and we are left with these terms: d2 sine star by dt is equals to what all terms? This is iota h cross, uh, iota h cross upon m. It will be 2m, 2m sine star d sine d2 sine by dx square, and plus, sorry, minus iota h cross upon 2m sine d2 sine star upon dx square, this term. So can I write it like this: d by dx 1 upon iota h cross upon 2m sine star d psi by dx minus psi, oh sorry, minus sine d sine star by dx. I can write it. If you will do the, if you will do the differentiation of these two with respect to x, you will find out that you will get four terms. Out of four terms, two will be cancelling each other, and you will get this. So you can do it by yourself, huh? So now put it here in this, right? D by dt minus psi plus psi dx is equals to iota h cross upon 2m, because we have found out the value of d by dt square sine star, right? And it is iota h cross sine star del x minus psi del psi by del x. Here you can see here there is one integration, there is one integration term, right? Integration, and d by dt value is differentiation of this. So you know the integration and differentiation will cancel out each other, and we'll get this term, right? Like in this way. Suppose you have x square. So you are doing first differentiation of it. So it is 2x. Now again do integration of it. So you will get the same term, right? So similarly here it is a differentiation, and put this differentiation in this term. And it is an integration. So differentiation and integration will cancel out each other, and you will get this term. Iota cross upon 2m sine star del psi by del x minus psi del sine star upon del x. Okay. If you and the limits are minus infinity to infinity, plus infinity, and I told you that the at extreme infinity, so the probability of finding out the particle at extrema is 0. So this will become iota h cross upon 2m psi star del psi by del x minus psi del psi star by del x is equals to 0. So this is the formula, right? This is the formula that we have calculated. Now, i- it is for 1D. Now, for 3D, you just replace it with like this, with this del. This del will contain all the term, sorry, all the coordinate x, y, and z. Okay. Now, what is the question? Where was where was the question? Okay, this is the question. So here in this question, can I'm doing calculation here itself, huh? Because then again I have to go back and forth. So I'm doing calculation here itself. Okay. Yes. 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 Integrated over all this space. See, minus infinity to infinity, na? It is the probability current density of finding out. If you have any doubt, you can refer which book, from which book I referred it. You can refer first chapter of Griffith quantum mechanics. You can refer this question if you have slight doubt about it. Now here you can see psi is a e raised to the power iota k r naught by r. Do with me, huh? If you have any, if I'm doing any calculation mistake, do with me. This will become, you can write a or a star. Anyways, it is a constant, so it will remain a. So e raised to the power minus iota k r naught by r. So what you need to do? First of all, do differentiation of this sign, del sign. So what will be the differentiation of sign? This is how much e raised to the power iota k r. This will be a minus iota h cross upon 2m a square. Okay, replace r by r naught. Sin star is this. So first I am doing the differentiation of this. This is a e raised to the power iota k r. Then k r will iota k will come like this. Iota k will come and then r naught by r, right? And one more is r naught by r. Okay. And one more is a e raised to the power iota k r, and this term r naught r1 will go in the r minus 1 minus 1 r2, right? And the other one is del psi star. This will be a e raised to the power minus iota k r naught by r. Yes. No, no. Mhm. Right. Okay, okay. Yeah, yeah, yeah. Yeah, yeah. Sorry, sorry, huh? A e raised to the power minus iota k r naught by r minus iota k plus, then again this will a e raised to the power minus iota k r naught by r square, right? Yes. So put this value here. Put this value. I have sin star value. Sin star is a e raised to the power minus iota k r naught by r. Hmm? And what is the value of del psi? Just calculate it. Del psi is a e raised to the power iota k r. Mm, can I'm using curly bracket to separate these two terms. Huh? Otherwise, there will be mistake. R naught by r minus a e raised to the power iota k r naught by r square. Okay. Then one more term is this term. This psi. Psi is how much? Uh, Psi is a e raised to the power iota k r naught by r. Then again in curly brackets del psi star. Iota k r naught by r minus iota k uh, minus a e raised to the power minus iota k r naught by r square. Okay, very heavy calculation. So iota h cross upon 2m. This term, first of all, this term, this will go if I'm multiplying this term inside. So it will become a square. This e raised to the power I minus iota k r plus e raised to the power plus iota k r will cancel each other, and r naught upon r square. and then iota k, sorry, iota k is also there, and the other term will be a square, other term will be a square r naught by r. Do with me, huh? If any calculation mistake is there, do. This will go multiply this will cancel each other, r naught by r cube. Okay, the next term will be here, from here a will give a square r naught by r whole square and minus iota k, and the other term will be, this is minus or plus, wait, let me confirm. This term is a raised to the power, then minus this term. Okay, so confusion. I mean, wait, let me see. There is so much confusion. A raised to the power. So you are done. Uh, because it's a problem magnitude, na? So it is us. They are asking magnitude. So magnitude basically 0.25 magnitude. So so I think here there is some confusion. So this will multiply this term, and we'll get r naught square minus iota k. So this term will become plus or minus. I think it is minus. So a square r naught by r cube, right? So there is minus here and there is minus here. So this minus minus will become plus. So this term will get cancel each other. Will cancel each other, and we'll get s is equals to. So since it is a magnitude, so you can write magnitude iota h cross upon 2m a square iota k r by r naught, r by r naught square. And if you see here, so they these term iota, this minus minus will become plus. So it will be 2 a square iota k r naught by r whole square. 2 a square iota k r naught by r whole square, right? This 2 will cancel cancel iota h cross upon m a square iota k. So here already minus is there. No minus, sorry. And this is r naught by r. So iota square is minus, and this is h cross, which I am not counting because magnitude is required, k upon m. This r naught, r is given how much? R is 2 r naught. Okay. A square h cross upon km. So this is 2 r naught. R is 2 r naught. This r naught will cancel, and you are asked to find out the value in terms of this unit, in terms of h cross a square k by m, right? So this is the unit. So here you got 1 by 2 whole square. So this will be 1 by 4, and 1 by 4 is 0.25 in the unit of h cross a square k by m. So you can see the formula is straightforward. This is, and you are asked to find out the magnitude. So first what you have to do, you have sine, just find out the sine star value, okay, and put that in this formula, you will get the answer. And in the question it is asked that you have to find out the answer in the unit of this. I hope this question is clear. So the next question is this one. Can we take 2 minutes break? I'll continue after 2 minutes break, huh? So yes, now I'm reading this question. Suppose a spin half particle is in the state this. There is some spin half particle. So this particle is in state this. Okay. What are the probabilities of getting h cross by 2 and minus h cross by 2? So this is the eigenvalues. There is some particle which is in some state, so it has eigenvalues. So what are the probabilities of finding the of getting h cross by 2 and minus h cross by 2 of z component of spin? Okay, so here if you can see, there is some particle whose eigenstate is given to us. Okay, so suppose this eigen wave function has some eigenvalues and it is given to us h cross by 2 and minus h cross by 2. So these are two eigenvalues of this wave, spin half particle that is in some state. Hmm? So you are asked to find out the probability of finding the particle. Sorry, you are they are asking in the question what is the probability of getting these values. So you should know the eigenvector corresponding to these values. When the particle, when it is z component is given, z component, so I am writing these eigenvalues, so you should know this. I mean, it is very important, huh? So when z component is given, z component is given, so the eigenvalue corresponding to h cross by 2 and the eigenvector associated with it will be this, sorry, 1 0, and from minus h cross by 2 it will be 0 1. This is very important, very important. And suppose in place of z component, if x component is given, so the vector corresponding to h cross by 2 will take the form like this: 1 upon root 1 upon root 2, 1 by 1. And for minus h cross by 2, it will be 1 upon root 2, 1 minus 1. And for y component, this is very important, huh? For y component, for h cross by 2, the vector will be 1 upon root 2, 1 iota. And for minus h cross by 2, it will be 1 upon root 2, 1 minus iota. You can write these thing. I mean, you can write for z component for h cross by 2, it will be 1 0, and for minus h cross by 2 it will be 0 1, these vectors. And for x component for h cross by 2 it will be 1 upon root 2, in matrix it is 1 1. And for minus h cross by 2 it will be 1 upon root 2, 1 minus 1. For y component you can write these because they are very important. Now accordingly, in the question, it is given z component of spin is measured. What are the probabilities of getting h cross by 2, these eigenvalues, if z component of spin is measured? Huh? There is some spin half particle. If z component of it is measured, so what will be the probability of getting h cross by 2 and minus h cross by 2? So we will see. We'll see here. So I have to go back again. Phi is 1 upon root 6, 1 plus iota upon 2. So we are asked z component. So can I write this like this way? Can I write this wave function as a linear combination of these two values which we are asked to find out? I'm constructing, huh? I'm constructing the vector. I'm constructing a state in terms of these two values which are asked to us, right? So from that I'll find out the probability. How, you will see. Now compare these two. Compare left hand side and right hand side. So you will get C1 is equals to 1 plus iota root 6 and C2 is equals to 2 upon root 6. So C1 square is the probability of getting the h cross by 2 and C2 square will be the probability of getting it in minus h cross by 2. 1 plus iota, 1 minus iota. 6. This will become 1 plus 1 upon 6. This will be 2 by 6 is equals to 1 by 3. And this C2 square will be 4 by 6 will be 2 by 3. See, in h cross by 2 state, the probability of finding it is 1 by 3. And for minus h cross by 2, the probability of finding it is 2 by 3. If you add it, the probability of getting it will be 1. Right? So this is the another way of checking your answer is correct or not. So this is for the z component when we have measured it along the z component. So we have constructed a wave function in terms of these two values. Now what about x component? In question we are also asked now to find out x component of spin is measured and getting these probabilities. So again same way construct 1 upon root 6, 1 plus iota by 2. C3 I'm taking this time. C1, C2 I have reserved it for Z component. Now I'm taking C3, C4. So what will be C3, C4? These will be for H cross by 2. The vector will be 1 up on root 2, 1, 1. And for C4, it will be 1 upon root 2, 1 minus 1. Now again, compare them. Do with me, huh? So that if any calculation mistake is there, you can inform me. And 1 upon root 2, C4 minus C4. This will be 1 upon root 2, C3 plus C4, C3 minus C4. Compare both the side of the matrix. So 1 plus iota upon root 6 is equals to C3 plus C4. I'm taking this root 2 to this side. And there is one more thing. And it will be 2 upon root 6 is equals to C3 minus C4. I'm taking root 2 this side. Now solve these equation. This is 1 and this is 2. First add these two equation. From no, it is root 2, not 2. On which line? I mean, you are asking. This is root 2. Equation 1, where C3 plus C4 because I'm adding these two matrix. Na? C3 plus C4. This 1 upon root 2. 1 upon root 2 will be in the denominator. So I'm taking this denominator to the left hand side. Right? For the solution purpose. I mean, not for any purpose. For the solution purpose, I'm doing it. I mean, you can take this root 2 in the denominator itself and solve the equation. This is for this to simplify the equation. Otherwise, there won't be any means anything in the denominator to. Okay. So C4 will cancel. I'm adding these two equations. So 2C3. So there is very less page here. 2C3 is equals to 1 plus iota root 6 root 2 and plus. Do with me, huh? If I'm doing any calculation mistake. And this will be 2 root 6 root 2. So C3 I'm directly writing. Huh? C3 will be 1 upon root 2, 3 plus iota root 6. Because here you will see this is 2 root 2. So this 2 will come, this 2 will root 2, root 2 will cancel and there will be root 2 in the denominator. So this term will come 2 plus 1, 3, 3 plus iota. So here you can solve it. Now, the next one is subtracting it. When you will subtract it, so I'm directly writing. I've already done this question. So when you will subtract this, you will get C4. So, so for C4, when you will subtract it, you will get 1, sorry, iota minus 1 upon root 6 root 2. Okay. Then again, I have told you to find out h cross by 2, you need to just square this C3 square term. So it will be 1 upon 2, 3 plus iota, 3 minus iota upon 6. And for minus h cross by 2, you need to square this C4 square term. So iota minus 1 minus iota minus 1 upon 6 into 2. So it will be C3 will come how much? 9 plus 1, 12. 10 by 12 is 5 by 6. If C3 is coming 5 by 6, so definitely the C4 will come 1 by 6, because 5 by 6 plus 1 by 6 is equals to 1. Na? And C4 will come 1, and this 1 will become 12, denominator 12. So 2 by 12 is 1 by 6. Yeah, this is so congested. I mean, this is so congested, but if you want, I can supply you the solution of it, because I guess this has become so congested. Okay, there is one more space. Sorry, my bad. Now the last part. Last part, I want you to do this. Calculate the expectation value of Sx. Calculate the expectation value of spin operator. Expectation value of spin operator Sx. You all can try this. It is very easy. How to find out the expectation value of h cross by 3. For which one? For which one? Third part. Okay. Third part, h cross by 3. Then it is right, because you have done this in this way, na? You are asked to find out the expectation value of this. So what you will do? 1 upon root 6 expectation value, huh? 1 minus iota 2. And you know, this x h cross by 2, the formula for it is 0 1 1 0. This sx is h cross by 2 upon h cross by 2 into poly spin matrix. This sigma x is poly spin matrix along x direction. So h cross by 2, 0 1 1 0, then 1 upon root 6, 1 minus iota upon 2. Do it. This is simple matrix multiplication. 1 minus iota 2, h cross by 2. I'm taking root 6 here. So this root 6 will become 6 into 2, 12. And here it will do 0, 2, h cross by 12. This 2 minus 2 iota upon n, 2 minus 2 iota plus 2 plus 2 iota. This will cancel. This will be 4h cross by 12, and it will be h cross by 3. So h cross by 3 will be the answer. I'll take questions related to this topic in the next class also, because this is quite difficult question compared to the other question that we have done previously. I hope this question is clear. So I'm moving on to the next question. So this question I want you to do. I mean, this question number 12. I want you people to do. This is very easy question. I mean, answer is given. I've already given the answer, but you just tell me that why this is not allowed by Fermi decay and allowed by Gamow-Taylor selection rule. This is question for beta decay, from beta decay. It is. I'll tell you. I'll tell you. So this topic. So that's why I've kept this question at the last so that I'll cover up beta decay. So can you? Can anyone of you tell me that why the answer is C? So if we see beta decay, so beta decay. Why beta decay generally happens? This is a nuclei. This is nucleus. It contains neutron or proton. Suppose when we have excess of neutron, or there is other case when we have excess of proton. So if such condition is this nucleus is facing, so this nucleus will find itself in an unstable condition. So to achieve the stability, if there is more number of neutron, so it will get converted into proton. This is known as beta negative decay. And if there is excess of proton, so they will get converted into neutron, and this is known as beta positive decay. Okay. Generally people says that neutron converting to proton giving electron. So earlier people believed that this is the only equation. Neutron is converting to proton and there is electron, that's it. But you know the energy distribution of beta decay, so it is a continuous distribution. Unlike alpha decay has a sharp energy peaks. So they found out that most of the electrons are emitted from the nucleus having energy less than the Q value. So where this missing value is going on? I mean, where this? Obviously, Q value is mass of the product, mass of the reactant minus mass of the product. But these electrons are emitted from the nucleus having energy less than the maximum energy, most of the electrons. So that means there is one more particle which is emitted during this reaction. So Pauli gave this hypothesis like there is one more particle, and that particle is chargeless. That is why charge is conserved on both their side, and the spin of that particle is half. So Fermi told that that particle is antineutrino when this antineutrino was discovered. So it was fulfilling all the requirement that was told by the scientist earlier for this beta decay. Okay. Now the next part of the beta decay is parity selection rule. So you can see here there is an element X with Z A. Z is element number and A is mass number. It is going to Z. If suppose it is a beta decay, wait, I'm just coming, huh? So we can see here that this is, if it is a beta decay, okay, where is my pencil? Sorry, problem from my side. Ah, so if this is a beta decay, proton will be emitted. So A will remain the same, and there will be an increase in one. Proton has emitted now electron and anti-neutrino. Okay. Now the parity selection rule says that this electron and anti-neutrino both have spin half particle, right? So for Fermi decay, okay, when the spin of these two particles are anti-parallel, that means S is zero. Then we have Fermi decay when it is parallel. aligned like this. S is equals to 1. Then we have Gamow-Taylor decay. Okay. Now, there is for allowed, L is equals to 0. Okay. And S is equals to 0 for Fermi, and S is equals to 1 for Gamow. Right? If you see here, now how this total angular momentum will vary. L minus L to L plus S, right? So when this L is 0 and S is 1, one case. When L is 0, S is 0. So 0, 0, it is 0. So no, it is 0. So there is one term 0. So this is for Fermi. This is for Fermi decay. And when S is 1, L is 0. So how it will vary? 0 minus 1 to 0 plus 1. Right? So it is 1. It is 1 for Gamow-Taylor. So J, delta J, where to write? Delta J has two values, 0 and plus minus 1. Okay, one is coming from Fermi, other one is from Gamow-Taylor. If you see here, if you see from this equation, it is going from 2 to 3, right? So delta J will be 3 minus 2 is equals to 1, and there is no change in parity. So you know parity is minus 1 raised to the power L, and minus 1 raised to the power L. L is how much? 0. So there is no change in parity. So parity is not changing. So parity is not changing, right? And delta J is equals to 3. L is 0 because this is for allowed transition. For allowed transition, we assume that the particles are formed at R is equals to 0. So ground state. So for ground state, L is equals to 0. We assume that particle is formed at R is equals to 0. That means electron and antineutrino forms at R is equals to 0. So that is why L is equals to 0. So delta J is 1. Okay. And you know that one is for Gamow-Taylor, not for Fermi. That is why it is not allowed by Fermi, but allowed by Gamow-Taylor selection rule. Right? But if suppose there is a case like this, 1 by 2 plus 1 by 2. Can any one of you tell me that from which transition it will go? Either it will go Fermi decay or Gamow-Taylor or both. No. Huh. Reason delta I is equals to 1 by 2 minus 1 by 2 to 1 by 2 plus 1 by 2. Yes. So both will come 0 and 1. So 0 for Fermi. Okay, sorry. And 1 is for Gamow-Taylor. Right? So that is why this decay will go by both. So there is one way like only Fermi, and there is other only Gamow, and there is mix of both Fermi and Gamow. So this one was allowed by Fermi, sorry, not allowed by Fermi, but allowed by Gamow-Taylor selection rule. Okay. So I guess I have covered all the questions that is there for in today's presentation. I hope so. Everyone of you understood. Okay, I'm ending the meeting, huh? And if one of you have, yes, yes, say question two. Okay.